In this video, I'd like to continue talking about multiplying and dividing complex numbers when they're in polar form. And we have the formulas for when we multiply or divide two complex numbers. And again, both of these numbers are first written in polar form, where we have the magnitude of the complex number, or the modulus, or the absolute value. And we also have the angle measured relative to the positive real number axes. And this angle is often called the argument of the complex number. And when multiplying the two complex numbers, we multiply their magnitudes and we add their angles. Essentially, we get a dilation and a rotation. And we can also divide these two complex numbers, and in division, we divide their magnitudes and we subtract their arguments or their angles. So we can apply these two formulas to our example problems here. For this one, we have W1 divided by W2. And since we're dividing, we will divide the two magnitudes and we will subtract the angles. And for the magnitudes, we have 44 over 4, which will simplify to 11. And on the inside of this expression here, we have the cosine of pi over 4 minus the argument of our second complex number in the denominator here. We have 4 pi over 3, and then we will add I times by the sine of pi over 4 minus 4 pi over 3. And we essentially just need to simplify the angle and this quotient here, which will just be 11. So let's work on the angle first. We have pi over 4 minus 4 pi over 3. We will give this a common denominator of 12, meaning we multiply top and bottom here by 3. So we have 3 pi. And top and bottom of this second expression by 4, meaning we have 16 pi. And this will simplify to minus 13 pi over 12. And if we want, we can look at a positive angle by adding 2 pi or adding 24 pi over 12 to this. And we will just get 11 pi over 12. But this angle is perfectly valid as well. It's a matter of preference at this point since these are equivalent to each other. Now, rewriting this quotient, this will be 11 multiplied by the cosine of 11 pi over 12. And actually, let me just use this negative one here. Minus 13 pi over 12 plus I times by the sine of minus 13 pi over 12. And let me make a little bit more room. And again, the way to interpret this quotient here is that the magnitude of this new complex number would be 11, and its angle, its argument, would be minus 13 pi over 12 radians. And this angle is measured relative to the positive real number axes. And since it's negative, that just means the angle would go clockwise. Now, let's look at one final question where we have multiplication, and with multiplication, we multiply the magnitudes and we add the angles. So we can write that W1 multiplied by W2 would be 3 times 5 multiplied by the cosine of 15 plus 45, which would just be 60, plus I times by the sine of that same angle, 60 degrees. And simplifying, we would have 15 multiplied by the cosine of 60 plus I times by the sine of 60. And when we interpret this new complex number, it has a magnitude of 15. Its distance from the origin is 15. And it's at an angle of 60 degrees relative to that positive real number axes. And if we want, we can graphically plot this. It's 15 away from the origin and at an angle of 60 degrees. So this length would be 15 and this angle here would be 60.